Now that we know how to create abstract classes and that we also know what abstract methods are, let's try and understand this from a conceptual perspective. What is abstraction, really? Abstraction means hiding of details. What do I mean by that? Imagine you are driving a race car. When you drive the race car, you only have a few controls. You have your steering wheel and you have your accelerator pedal and your brake pedal. And there are some other controls that allow you to do certain things in a race car. However, there is a lot of technology under the hood of that race car. When you are driving the car, you do not know how the engine works. You do not know how the fuel is used. You also do not know how drag is reduced. And there are a lot of other things that you do not know when you are driving the car. All of those details are hidden from you. All you know is that you are driving the car using the steering wheel, the brake pedal, and the accelerator. The details of the internal mechanisms of the car are abstracted away from you. They are hidden from you. In the same way, let's say you are using something much simpler. Let's say you are using a computer mouse. All you are doing is moving the mouse with your hand, and you see the cursor on your computer screen move as well. You do not necessarily know the internal mechanism of how the movement of your hand translates to the movement of the cursor on the screen. That technical detail, the internal mechanisms that allow the mouse to work, all of those details are hidden from you. We say that all of those details are abstracted away. So abstraction means hiding details. Now let's understand something. Our main objective is to create objects. Ultimately, when we are creating a program, what we essentially do is that we create a lot of objects that interact with each other and make our program work and give us the results that we want. So let's say we have to create all these objects in order to make our program work. Whatever program we're writing. The way we create objects is by using classes. You must remember the example that we did with cars and planes and trains, right? So let's say we are creating cars, trains, and boat objects. So classes are blueprints for our objects. Classes make it easier for us to create our objects, which is why we call them blueprints of our objects. That's what we learned in the very beginning of this course. But then we also learned about inheritance. So we could say that we might have a vehicle class, and all types of cars and trains and boats inherit from our vehicle class. Now, of course, there could be more classes here before we create our objects. There could be a Toyota class, there could be a Ford class that inherit from the car class, and we could create objects from those classes. So if you really look at this, everything on this side is basically our attempt to create a structure behind those classes. And ultimately, when we have the final classes, we can just create the objects directly from there. But all of this is a structure that allows us to ultimately create the object that we desire to create. And that is what we learned up till inheritance. Now we have seen abstract classes as well. So we can create abstract methods in the vehicle class, let's say. And what that does is that it forces anyone who inherits from vehicle class to implement those abstract methods. Of course, the vehicle class becomes abstract in the process. But when the vehicle class becomes abstract, meaning that we include some abstract methods in the vehicle class, we do not provide the implementation of those methods in the vehicle class. What we say is that whoever inherits from the vehicle class must do the implementation of the methods that the vehicle class wants to be implemented. So if the vehicle class wants to implement a drive method as an abstract method, what it is essentially doing is that it is forcing any class that inherits from the vehicle class to implement a drive method. So in that case, the class has to override and implement its drive method. The train also has to override it. And the boat also has to override it. If the car class does not override it, then someone else in the chain must override it. So if we are following this chain, you see the drive method has been implemented somewhere, and the only reason it got implemented is because the vehicle class forced it. The vehicle class created an abstract drive method and said, I don't care who implements it, but whoever is in the chain, any one of them must implement it. Of course, this means that if we are following this chain, then in this chain, the drive method has not been implemented. So in this case, Ford has to implement it. So no matter what, ultimately, the classes that are concrete and which can be used to create the objects all have to implement drive methods. And that is only because the vehicle class created the abstract method drive and forced everyone to make sure that the drive method is implemented. So now the drive method is implemented in this chain and also in this chain. And so all these objects will have access to some drive method. Of course, their drive methods would be different because they would be coming from different vehicles. So what I want you to understand is that the abstract classes are acting as if they are blueprints of the other classes. The abstract classes dictate what the other classes have to implement. The other classes can implement their own methods as well, but regardless of whatever they do, they must implement what the abstract class asked them to. So I think of it as blueprints for classes. Just like you have classes which are blueprints for objects, because classes dictate what objects can and cannot do. Abstract classes also dictate what other classes must implement. So in my mind, abstract classes are also a kind of blueprint. And so we can think of it as an even deeper layer of the structure that we are building. So then this becomes the object layer, this becomes the concrete class layer, and this becomes the abstract layer. Now, when you are coding, you will create a lot of classes, and sometimes you will inherit from some predefined classes. A lot of those predefined classes are abstract classes. So you do not know how those abstract classes are implemented. You do not know what is happening inside those abstract classes. But when you inherit from that abstract class, you will keep on getting errors until you implement the code for the abstract methods from those abstract classes. Sometimes you will create your own abstract classes, and maybe someone else might want to use your abstract class to create their class. They might want to use your abstract classes and inherit from those classes in their own programs. In that case, they will not know how you have implemented things in your abstract class. All they would see is that there are some requirements that if you inherit from my abstract class, you must implement some methods. For example, in this case, it was drive. Every class that inherited from the vehicle class understood that they have to implement the drive method. What this is doing is that it is creating a separation. It is creating a hierarchy. The abstract class is hiding the details of the implementation of a vehicle. If we want to create a vehicle, we do not need to know the different parts or the overall design of the vehicle. All we do is inherit from the vehicle class, and then we just understand what methods to implement. We implement those methods, and then we create those objects. The vehicle class dictates which methods must be implemented, but the details of the vehicle class are hidden from us. If we look at the animal example that we saw in the previous video, it is the same story. We have the animal class, which is abstract. We have the mammal class, the bird class, and let's say the fish class that inherit from the abstract animal class. And we have the lion class and the zebra class. The animal class has eat and breed methods, which are abstract. And let's say that's it. Let's say the animal class is something that someone has created. Now we want to create a few animals. What we do is that we know we have an animal class, which is abstract. All we do is we inherit from it. And then we are forced to override the eat and the breed methods. Of course, mammals, birds, and fish can have their own methods as well, but because they are animals, they also had to implement the eat and the breed methods. So they are being guided by the animal class. the animal classes, guiding them towards creating a functional animal. However, they do not need to know what's inside the abstract class. The design of an animal is hidden away. It is abstracted away. So I hope you understand the intuition behind abstraction and the hiding of details. To make things a bit more clearer, think of a phone class. Let's say you are designing what a phone should be able to do. And so you design an abstract class. You say that whatever phone you want to create, if you inherit from the phone class, then regardless of what kind of phone you're creating, you must implement a call method, you must implement a text method, you must implement a picture method. And then this abstract class can have some concrete methods of its own. But whoever inherits from this abstract class does not need to think about the design of the phone, the design of the basic workings of the phone. That has already been thought of. Here, someone has already thought of all those methods that are needed and put them in the abstract class. If we want to create a phone now, all we need to do is inherit from the phone class, and then we'll keep on getting instructions about which methods we need to override and implement. We do not need to think and come up with the basic methods that a phone needs. That design has already been done in the abstract class. In this way, the design of the phone is hidden away from us. All we are getting are instructions about what methods to implement, and then we implement it, and ultimately we have a functional phone class. And from there, we can create objects. As I mentioned earlier, you can think of this as a blueprint of other classes that want to create phone objects. Just like classes are blueprints for objects, in the same way, abstract classes are kind of blueprints for classes that inherit from them. So in that case, this phone abstract class will be a blueprint for any other class that wants to create phone objects. And then they can follow this blueprint and create their own type of phone class. So concrete classes are blueprints for objects, and abstract classes are kind of blueprints or guidebooks for concrete classes. And that is the intuition behind abstraction.